introduce you our next speaker. It's Ercan Uslular. Ercan graduated from Çukurova University. Ercan started his career in Temsa, Austria, and managed operation of Temsa Global. Ercan joined Alapala team in 2015 and since then supports Tepart from team as an after-sales manager. Ercan will talk about predictive maintenance. Welcome, Ercan.
Thank you, Martin. First of all, thank you for also IAOM team that such a technical forum will help and will give some beneficiary important infos to all of the joiners. And let me share my screen. I hope my screen is seeable. You can see my screen, I guess. Yes.
Yes. Yes.
Okay. So as Martin already said, my name is Ercan Uslular, and I'm dealing with after-sales issues around, not around, exactly since 22 years, and the last 7 years I am in the milling sector, and I'm trying to implement after-sales systems to the company which I am working. So what we will talk about today in the forum, I will tell about shortly, make some brief explanation about predictive maintenance and what will be in our agenda, in our content. First, I would like to give a short explanation, a brief explanation about Tepart, what is Tepart doing and what they are dealing it, and then we will jump to maintenance methods. Then we will talk about our predictive maintenance. What is predictive maintenance? How does this predictive maintenance work? Then we will talk about some technologies which is using in this predictive maintenance. Then I will show also some samples in our company, what we are doing for predictive maintenance, some samples on the roller mill. Then we will talk about shortly the advantages and disadvantages, and then we will conclude with the summary of predictive maintenance, and then I will let you about the question session. So Tepart is a group company of Alapala Group, which is selling spare parts and giving after-sales services. We are providing spare parts all around the world, not only for Alapala mills, also for the other brand mills, also nearly in 80 countries. Besides the spare parts business, we at the beginning of 2020, Tepart has expanded and also bring after-sales solutions also in the company. And since 2020, all Alapala customers, and also not the brand of Alapala, also the other brands, we are giving spare part and after-sales services. So let's start with some brief information about maintenance. As all you know, we can divide it in two main groups. This maintenance, this is reactive and proactive. Reactive is the most known maintenance that nearly, I can say 30, just a moment, I have also, I can tell it is nearly 30% of the companies are using this reactive side. As mentioned also on the screen, as I mentioned here, is too late means after the incident has happened, we are acting and to solve the issue, and this is most costing too much to the companies. And the other side, the proactive type. The proactive type we can also divide it into two groups as preventive and predictive. The preventive is actually, we can call it as too early, means we are making regularly maintenance scheduling, and sometimes, for example, a bearing change can be early, but we are changing according to it. And predictive, which we will talk about today, is actually directly right on time. That's why we can say predictive maintenance is so much important nowadays in our life. So on the graphic, this graphic is actually well known when you make a search about predictive maintenance in internet, or when you can see directly one of a few graphics, and one of this is the one of them. And as you see, it is summarizing very well actually the importance of the predictive maintenance. As you see on the zones, after the incident is happening, when you get some remarks like the noise or some smell, some burning smell or something, or some system damages, then you will see that the cost, as you see on the red zone, is getting high and high. But if you are available to monitor something like vibration, like temperature, and analyzing this, then you will see that your cost is getting low and low. Also, let's start with what is predictive maintenance. I was really surprised that after I read some articles, that I see that in Turkey, for example, it is announced in 1988, first of all, this predictive maintenance. But I don't think so that it was not, has been taken as serious as today. And also nowadays you can read everywhere this predictive maintenance. It's also a step from the industry 4.0, which is mainly focusing the traceability of your equipment. So what is predictive maintenance? Actually, predictive maintenance is monitoring the data which has been taken from the machinery for detecting the possible breakdowns. So preventing the downtimes because of unknown and unplanned maintenance activities. Actually, the goal is optimizing your resources, your maintenance resources. And when implemented successfully, you will see that predictive maintenance lower your operational costs and minimize your downtime issues and improves your asset health and performance. So predictive maintenance, I'm not meaning here about implementation, but actually predictive maintenance has 3 steps. I can categorize as in 3 steps. These are measuring, analyzing, and repairing. What I'm telling with measuring, you should firstly assign some critical points which will which should be to be analyzing, which actually is very important in your production, which affects your production when it is as a breakdown. Analyzing the source of the failure should be analyzed, and then the maintenance team should schedule the fix the mentioned or how can I say, the fault codes. So here is a basic chart. When you look in the internet or somewhere, you can find some graphics which can briefly explain. Here you can see also on the left side, you should firstly decide which equipment you will going to monitor. Then after your monitoring, you should collect the data and make some analysis, and then you should put this analysis to the collection data as then you should start to start your repair plans then the repair, then the repair plans has taken a role on the, and this will be a closed cycle. For example, here is also the first step is to establishing and installing the monitoring, collection the data, and then the identification. You will start to create the work order, perform the maintenance, and this will be a closed circle later on. So with this PDM, predictive maintenance, we are going to use some technologies. For example, the technologies is the condition and monitoring. This gives us the real-time performance and machine health data. Some IoT technologies, Internet of Things, and these are the communication between the machines and software solutions like sensors, this and that, etc. And then for the failure predictions, we are building the predictive algorithms. So all these data are processed, and they can we can take it out the failure predictions, and then the maintenance teams are doing with these failure predictions, they are preparing their maintenance schedules. So when we start to implement, let's go a bit more deeply about how to implement predictive maintenance. Actually, it is summarized around 5 and 6 steps. It depends on the factory, how big is it or how small is it. So first of all, you should identify the critical assets. What I mean with critical assets, which has a high repair cost or which is really more critical for your production. At the beginning, it is not advised as to make all of the assets to prepare for predictive maintenance. That first of all, you should choose some pilot assets, and then, as I mentioned here, with high repair cost or critical, which is critical for production. After choosing the identification, then you should start with establishing the database. From the how you will establish it, you can establish it from the maintenance records, charts, and also, which is more important, the technical experience, the technician's experience. Then the failure analyzing. Failure should be analyzed, and failure models should be established. Then implementing the PDM technologies. As I said before, what I'm saying about technologies, for example, some sensors, appropriate sensors. But first of all, before you spend money on this topic, you should be sure that your equipment is suitable for implementing such technology. Then developing the algorithms. For this, such developments, mostly the companies do not have the suitable person, or how can I say, such skilled personnel. That's why most of them are organizing some or hiring some data analyzers for this issue. And then as the last step, this is the testing session, actually. If the process is executed properly there, then you will see some significant improvements in the company. And then if you see, and if you say it's okay, it has improved my maintenance, if it's reduced my cost, then you can start to implement for the other machineries as well. So now I would like to give some sample on our roller mill, what we are using. Okay, we are using lots of sensors. Also, other brands also they are using, just to make the operator's life easier and also for the efficiency of the machinery. We are using lots of sensors, but I will talk about some of them which we are also using for predictive issues. For example, the vibration sensors, which we are using really a maintenance tool for the predictive issues. And this will also, how can I say, a good detection for also for the bearing lives. As you see on the left side on the screen, the vibration analysis, it can be readable, and by data analysis, if there is some, after the collecting data, the data analyzers are making some, how can I say, failure outputs, and according to this, when we see on the screen such failures, we can, how can I say, we can directly get in touch with the maintenance team, and the maintenance team can make the necessary change or repairments before the breakdowns happen. Also, for example, the main role temperature sensor, what we are using. If the heat distribution is not good enough, this will also affecting the grinding efficiency. This going to step by step affecting also your quality as well. And as everybody knows, if the quality is going worse, also this is a how can I say, a loss, and it will be a cost for your company as well. As some samples more, like rotation sensors, some temperature sensors. For example, the temperature sensor is also well-known predictive technology that it will give signs before some damages happened. This will also helpful to make the maintenance plan for the team. An interesting thing also, the human detection sensor, because not always is our team, also the workers, is not always running around the machineries. And then with this, for example, with this sensor, you can also save time and energy, because it is operating when he senses that there is someone, then the panel is opening and waits in standby. And another thing, the air pressure sensor. The air pressure sensor is also give some info about the loss in the pneumatic system, which is directly related with the grinding pressure, and it warns the operator to make some precautionary actions also. So when we go to the advantages, you can see on the screen there's lots of advantages, but mainly the smart replacements for the cost reductions, the recovering the revenue, decreasing the service losses, improving the workforce, such well-known advantages. And beside this, there's also some, I cannot say disadvantage, but some concept about it, the PDM technology. Why I'm saying the PDM technology? Because the sensors, or installing it, or if the equipment is not suitable, it will be a cost occurring to the factory or the company. And the data analyzing is a huge job, and for this you need always skilled staff, and this is also causing a cost to the company. So according in some, when I checked some articles, there's also some numerical outputs. For example, as on the screen from the US Department of Energy, they make some surveys and they find out that they are mentioning after a well-implemented predictive maintenance is going to reduce the maintenance and repair cost around 25 and 30%. The breakdowns around 70 and 75%. And the reduction in downtime, it's nearly 35 and 45%. Also, in one of the, I have read an article there from, for example, from Mr. Steve Carr. In the article, he mentioned that the actual cost for a breakdown is between 15 times of the maintenance cost. This is a very important point also. And also in the same article, it says also that the cost for a machine breakdown is not only the repair cost. It is a very meaningful sentence because, okay, we just when we as technical teams, when incidents happen, we are just focusing on to fix the problem as soon as possible. But on the other side, also on the financial side, also the management side is focusing, okay, during this stoppage, how much money we are lost. This is another issue also. That's why I am fully agree with Mr. Steve Carr that the cost is not only the repair cost there. So again, from some academic researchers, the chart at the beginning I show, and also this chart, as you can see everywhere, also in some, when you make some technical searches for Industry 4.0, then you will see also these. But here you can see clearly that the total costs of the optimum level of maintenance and the cost of the production losses and the overall the total cost is decreasing with an improved PDM, predictive maintenance solution. So as a conclusion, I can say that the cost of downtime has a big impact on the profitability, yeah. But and already in most of companies, the world-class companies, they are implementing a new business service models like this predictive maintenance. But changing from predictive to from preventive to predictive is also not so easy. But as I said, implementing predictive maintenance requires a significant investment in money, in HR, in human resources, personnel, and also the education for them. This is actually my presentation in short and brief explanation. I hope something is in your mind now about predictive maintenance. And now, Mr. Martin, we can go through the answers, question and answer. I hope I can answer all your questions.
Thank you, Ercan. Thank you for this interesting insights about predictive maintenance. I'm sure the questions will come on the chat. I will start with first question, listening to you and getting the step for implementation. What is needed from the miller side and what is needed or what has to be provided by the machine supplier?
Actually, what is needed from the miller side, I can say, as I mentioned already 2 or 3 times about the human resources. I mean, not only for the miller side, also the the companies, for this implementation, they need really trained staff for it. Or I can say companies are doing this predictive maintenance, sometimes with their sources, and sometimes they are outsourcing this issue. Or they can make a hybrid solution, and some topics they can do it by themselves, and some, for example, data analyzing or something they can outsourcing. This is one part of it. And from the machinery side, what they are actually nowadays, I am also in a company that's producing machineries. They are at the moment, when I check also, when we make some benchmarks, already the companies are using electronical tools are, how can I say, the electronical tools they are using at the moment are all applicable with these PDM technologies. That's why with the new machineries, I can say it is more easier to implement predictive maintenance. But for at the beginning of my presentation, as I said, first of all, they should check if the machinery is suitable for applying some PDM technologies. Yeah, shortly, I can say like this, Martin.
Thank you, Ercan. I'm still wondering, if I'm a miller, I have existing equipment. What do I have to do to implement predictive maintenance?
So, first of all, you should check which assets, which machineries is for you, how can I say, how can I say, it is most important part of your mill. For example, a roller mill. When it's stopped, it will affect all your process, or sifter, for example. That's why, first of all, you should, as a miller, you should decide which machineries are critical for you. And after then, actually, it is not the scope, in my opinion, of course, it is not the scope of the miller that how it will be going to a sifter or a roller mill is going to be more, how can I say, smart. I can say actually smart, which you can able to collect some data for it. But in my opinion, on the miller side, for the predictive maintenance, is the most critical thing is to choose which equipment should be more smart than it is now.
Good, thank you. Can I put everywhere, can I make every machine smart? I'm a miller, I'm talking about the plant sifter.
Yeah.
The sieves are critical, can break anytime. Now, how can I apply predictive maintenance on a plant sifter?
So actually, I cannot give such deeply technical detail, but I can say like this, okay, for the plant sifter, as you said, your sieves is very important. For the sieves, maybe the temperature, which is inside the plant sifter, is a critical point. The vibration, it's a hanging machine. The vibration, if it is there is abnormal vibrations, for example, will affect the bearings of the sifter. That's why a vibration sensor, for example, and then the heat, when it's overheated, will affect your sieve boxes also. That's why it's coming up to my mind, for example, to observing the vibration and heat will be a step for predictive maintenance. I can say.
So am I right if I say all what can be measured by sensors can be integrated in predictive maintenance?
Exactly, exactly. But then the thing is coming that all of these data which you are collecting should be analyzed. And this is actually the huge job.
So would it be then the solution a mix of preventive maintenance and predictive?
Actually, I can not.
I'm coming back to the sifter.
Yeah.
A sieve breakage can't hardly be detected by a sensor. So I only realize when the sieve is broken. It's not the temperature, not the vibration. Nothing can tell me when a sieve is broken except the product coming off, which is different than it should be. So sieve control of the replacement of sieve, should it be done by preventive or predictive?
Actually, Martin, I can say here this. If you are going to apply a predictive maintenance on your mill or on your company or your factory, not only mill, I am talking about, it is always, when I make some searches, it shows that it is always more, how can I say, more effective if you have already a preventive maintenance at the factory or at the mill. Just from the reactive to predictive jumping is sometimes is a catastrophic results. But if you have already a preventive maintenance on your mill or factory, etc., then the predictive implementation will be easier. Yes, according to your questions, yes, in some parts, as you said already, you are correct. Preventive and predictive will work together, yes. It will be actually also a data collection, because during the preventive maintenances, as you said, when your maintenance guy is checking the sieve boxes, etc., he will also see some, if he's going to see some damages, he will also report to in his reports. And this data, as I mentioned already in before slides, this the technician's experience is also taking a big role on the predictive side. Yes.
Good. Any questions from the audience? I see no question in the chat. Now, Ercan, is it expensive to implement predictive maintenance?
Yeah, yes, predictive maintenance is expensive. It depends on, I can say, it's a really difficult question to answer, but depending on the objectives or the machineries and also the size of the factory or mill. If you have a small mill, a middle-sized mill, it will be, I can say, expensive. But at the end of the day, a successfully predictive maintenance program will significantly reduce your energy costs and maintenance costs. Then it is, I can say, yeah, for the big companies or big mills, it is, I can say it is expensive but tolerable. But for the small companies, just for a few machineries to do it, I can say it can be expensive. Yeah.
Then it's just many mills are existing and running since many years. Is it recommended to upgrade existing equipment to implement predictive maintenance?
Is it actually, as I told Martin, it is actually, first of all, for the existing mill, if it, from reactive to, first of all, to get proactive, and firstly of preventive maintenance. And after the preventive maintenance, yes, and it will be very helpful and cost reduction for implementing on some machineries. But as I said, first of all, starting up with one or two machines, and then later on, after observing if there's because it can be changed because of the, how can I say, the personal, the conditions, environmental conditions, etc. But after the first one or two machines as using as pilot, and then observing, and then if you are observing the maintenance reduction, then you can continue with the rest of the machines to upgrading the machineries to preventive, from preventive to predictive. Yeah.
Thank you, John. In this case, just my final question. When should I start with a PDM program?
Yeah, when you should start. As I said, I am always repeating the story for it, but when you should start, you should be familiar with the maintenance issues. That's why I always recommend that you should start after, if you have a preventive maintenance, a good running preventive maintenance program. Then really I don't recommend that from reactive maintenance to jump directly to a predictive maintenance. That's why if in your mill or in your factory you are using reactive maintenance, then I am really recommending that the first start with preventing type, and then to spend some money to predictive side.
Thank you, Ercan. Very valuable inputs. It's a good food for thoughts.